All, this is Dr. Mobeen Sayed from drbeen.com. Welcome to one more show. So happy holidays, happy advanced new year as well. I was actually going to be off for till the next week, but there are three topics that just popped up. One is the situation in China. The other one is the study IgG4. And there is one more topic that was interesting. So let's see what we can do. Today we'll discuss this topic. Uh, what I'm going to do is I'm going to go over the study and explain the mechanisms and explain the findings of the studies, not the rumors and not the conspiracy theories and not the clarifications that are being put together. I'm seeing some Twitter doctors who are clarifying, and even their clarifications are incorrect. And I'm seeing many folks who are vaccine hesitant, vaccine disliking, anti-vaccine, and they are putting together lots of just crappy interpretation. So let's look at what is the study itself saying. So I'm going to share my screen, and this is the drbeen.com. In the description of this video, there is a link, and that link gives you access to drbeen.com, one-time fee only, for $67, one-time fee, 900 medical lectures. And I was discussing this with one of my friends. We are planning that by mid-January, we will launch Dr. Bean videos as courses. So we'll have, for example, cardiovascular pathology or cardiovascular physiology or immunology, and those courses will be individually sold. So there will be no more lifetime sellings. This is the last couple of weeks or 3 weeks about that we will stay with this. We were writing technology to be able to sell courses and give access to a fewer videos per course. So that technology will be rolled out by mid-January. So here is an opportunity. This is the study. This study, class switch towards non-inflammatory, spike-specific. This is very important. I'm seeing so many people not looking at this word spike-specific and becoming all scared and even fear-mongered. IgG4 antibodies after repeated SARS-CoV-2 mRNA vaccination. Specifically, Pfizer is the vaccine that they looked at. So it may not be with Moderna, or it may be, but that is not included. This is the study. We'll look into that. Then these are the tweets. The study was tweeted more than 5,000 times. And there are all kinds of conspiracy theories here. There are all kinds of clarifications here. And many of these are actually incorrect. Then there is a link in the description for what do we mean by affinity maturation and affinity of an antibody versus avidity of an antibody. And why do I have this link over here? Because we're going to talk about that. Then similarly, there is antibody-dependent cellular cytotoxicity, antibody-dependent phagocytosis, cellular phagocytosis, antibody-dependent complement deposition. I am going to explain all of those one by one. So I'm going to take a lot of pain today to explain this, but the point of view for explaining this is that we don't get lost in the technicality of a study and then become misdirected. So I'm going to explain these as well. And with that, let's start with one of the paintings. So there is a very good painter. Her name is Vicky McMurray, and she does great work. And I took one of her painting. I actually have her book. It was sitting somewhere over here. So I took one of her studies and made a painting of that. She called that golden glints. And this is my interpretation of that. So this is the painting. And now let's start. So these are gifts for humanity, and they're continuing. I want to give a shout out to Margaret McInnes. She has once again sent a very good donation. So thank you very much, Margaret. Okay, so here are the notes for this study. The study itself is worth reading. After these notes, it would, I think, enable you to read it more clearly. So, first of all, the researchers, I think it is a Spanish study or German. Uh, it's not a US study. So they had a cohort one, 29 people in it. Then they had another cohort two, 38 people in it. Cohort one was the actual cohort that they were working with, small study. So that means it does have its limitation because of the small size. These were Pfizer community vaccine receivers, 3 doses. And then just to make sure that what researchers are seeing is actually the case with this vaccine and it's not just a fluke, they had one more cohort which was also 3 shot vaccinated, and they also looked at their data as well to compare to this group to make sure that they are looking at the data that is only present in vaccinated. Now what they did was they looked at the serum, they took the serum collections after first, second dose, third dose. And the first and second dose were 3 to 4 weeks, as is the primary series. And then the third dose was about 7 months after. And these were healthcare workers who participated in this study. It was a longitudinal study. That is, they took their serums, then they continued to look at them for up to 200 days. And what they saw was, or what they were looking for was, they were looking for the antibody responses. So they looked at the antibody responses after each dose within 10 days of the dose. That could act as a baseline, right? So if you give me a dose today and then you take my blood serum within 10 days, you will see the vaccine hasn't yet done a lot. And what is the antibody levels that would become a baseline? Then they would look at, after the second dose, they took the serum even up to 210 days. And then after the third dose, they took the serum samples even up to 180 days. So it's a longitudinal study. Very interesting study, actually. I loved this study. As much as I saw that people are tainting it by misusing it, misinterpreting it, scaring others with it, it is actually a beautiful study. So observations were made for the following. What they were trying to figure out is antibody types or classes and levels in community versus adenovirus-based vaccines. So they were saying, here is the vaccine type A, mRNA vaccine. Here is adenovirus-based vaccine. What kind of antibody levels they produce? What is the performance of these antibodies? And what are the classes of the antibodies? IgG4, for example, is a class. IgM, IgD, IgG. So these are classes. What are the classes of the antibodies? And then what is the performance? For example, neutralization or binding or inflammation and so on. We'll discuss more. They also, this is important, they looked at ADCP, antibody-dependent cellular phagocytosis, antibody-dependent cellular cytotoxicity, ADCC, and antibody-dependent cellular, complement deposition. I'll explain those in a minute. The general idea they gave here was that all of these functions were reduced in the presence of IgG4. And from this, they said, it seems like IgG4 when increased, and these IgG4 has low potential to cause these mechanisms to be activated. That means it is kind of anti-inflammatory compared to IgG1, for example. And do you know what they actually said? So it is interesting for me that there was a time, there still is a time, when people say that, hey, vaccines are bad because they cause antibody dependent enhancement, ADE. Now, here is a study that demonstrates that vaccine, when the third dose is given, do not cause antibody-dependent enhancement. All of these antibody-dependent enhancing functions are reduced. And now I'm reading articles and blogs that are saying this is so bad. We wanted the antibodies to really do well. We wanted them to cause inflammation. And here we have the antibodies that are not causing inflammation, and these functions are reduced. So it's almost that on one end, we want no ADE, and on the other end, we want ADE now. So it's just misguiding by various bloggers. Okay, continuing. What is the big finding? What did they find in this study? Here is what they found. And I think this is the first time that a study found this. That as we continue to repeat mRNA vaccine, this is not true for adenovirus-based vaccines. This is also not true for a mixed and matched vaccine where there is maybe one dose of mRNA and the other doses are of adenovirus. That was the case in Europe. Remember, Europe had given adenovirus-based vaccines first, and they found out the side effects of that. Then they said, fine, let's move to mRNA. So adenovirus only or adenovirus plus mRNA did not have this phenomena. Only mRNA vaccine and third shot caused this. What did it cause? It caused, so if you see here down here, it caused an increase in IgG4 class antibodies. And that is what I'll explain what it is and how does it function. But let's look at their finding. It found more IgG4 antibodies. Here is if you just wanted to stop here and say, all right, just tell me what the heck did they find? How serious is this? What they found was before the third shot, IgG1, and I'll explain that later, but IgG1, which is a pro-inflammatory protective antibody, IgG1 was, let's say, I'm making up a number, 90%. I'll show you the actual numbers in a second. And IgG4 was not even present. Then after the second shot, IgG1 was still 90%, and IgG4 became, let's say, 2%. After the third shot, IgG1 became 70, 72%, and IgG4 became 19, 20% of all the spike antibodies, not all the body's antibodies, all the spike related. They say it in their what is that? In their title, spike specific. So if you go here, class switch towards non-inflammatory spike specific IgG4. It is not all antibodies. Why am I saying this? Because there is a person who has made people afraid that this is why cancers are happening. So spike specific IgG4 will not cause cancer because the remaining antibodies are all fine. It is only spike specific antibodies where IgG4 level relatively increased. IgG1, the main protective pro-inflammatory antibody, was still 70%. That is a very important thing to keep in mind when you're reading the study or reading people's blogs about it. They omit the actual relative percentage change, the bloggers, and they simply make it look like if the IgG4 has just changed and the body has just switched from others to IgG4 and now we're in trouble. That is not the case. IgG1 is still 70%, which is more than ample actually help against the infection, whatever help. We know these vaccines aren't helping for infection a lot. They may be helping with severe cases, but not with the infection. So keeping all that in your mind, so that is a grain of salt that we already have, that these vaccines aren't performing very well. So keeping that on a side, IgG1 is still the 70%. IgG4 is lesser. So I'm going to move forward. The other thing that they found was that, let's say this was a second shot somewhere over here. Let's say this was second shot. So of course the antibodies increased and then they waned. We know that within 2-3 months they all start waning. But when they gave the third shot, then immediately after the third shot, the antibody levels started increasing, right? So that is this. And then they would start waning. It is an interesting thing. IgG4 started rising 2-3 months after. It was a slow rise. And then it sustained and did not wane, at least not during their time. So that time when the IgG1 was rising and then waning, at that time IgG4 wasn't too much there. And then IgG4 started rising and stayed risen. That means there was a gap in protection time, which may be the time of infection. Okay, so let's look at this. This is from their paper. This is the relative change. So let's look at this. After the second dose, so here IgG4 is the green one. IgG1 is the blue one. So look at this one here. Majority, 88%, 90%, about 88.98 was IgG1. And IgG4 was about 8%. This is after the first shot. After follow-up I said first shot. This is the second shot. Then follow-up post-second shot, that is a few months later, even up to 210 days. If you see here, IgG1 is 85.97% and IgG4 is 4.82%. Good. So that's the second. Then third dose, look at the IgG1. It dropped from 85.97 to 77.09. It produced room. And what happened? The other IgG4 moved up from 4.82. Remember, it was 7.57, then it was waning down to 4.82. After the vaccine, it went up to 13.91. This is the first anomaly. Anomaly is that, all right, all antibodies will go up, but the IgG4 relatively went up more. Right? So, John Snyder made a comment, we can't say they aren't doing great. If the class switch to IgG4, which is not inflammatory, is what reduces, absolutely, I was going to make that comment a little later, that it is actually, in my opinion, a good thing that body has found a way to balance out the inflammation. What does the spike protein and COVID have common in them that causes the damage? That is inflammation. So if body makes IgG4, which is anti-inflammatory, that should actually make the situation milder. This may be the reason some long COVID patients feel better after a vaccine dose. This may be the reason that inflammation in general for spike protein, whatever infection or vaccine injury, in some people is reduced after the vaccine dose. So yes, you're right, John. I just wanted to go in a structured way to talk about it at a later time. But anyways, here is the comment. Okay, so post third vaccine, the IgG4, which is relatively anti-inflammatory, it's not actually, I read in a tweet, it is potent anti-inflammatory. No, it is not potent anti-inflammatory. It is relatively anti-inflammatory compared to IgG1. So 13.9%. And look at this follow-up. So follow-up is up to 180 days. The IgG1 was still 72.58%. Nobody is talking about this. And IgG4 became 19.27%. Now, I want to add one more comment here, which actually belonged a little later, but John, credit to John, he started this discussion. So let me make that point here as well. IgG4 related diseases. IgG4 related diseases or IgG4 RDs. These diseases are present in people who have IgG4. About 40% of overall immunoglobulins, IgGs, are not all immunoglobulin, but IgG immunoglobulin, 40% of them are IgG4 in them, in these patients. That is not the case here. Here we're only talking about the anti-spike IgGs, which may be for all the IgGs, it may be a small fraction. Then within that fraction, we're talking 20%. It does not rise up to the level to be able to cause IgG4 related diseases. And number two, this is very important, even for, I'm sure that rheumatologists know this, immunologists know this, but many physicians also do not know this. IgG4 related diseases do not occur because of the IgG4 antibody itself. That's not the case. What happens is, in these patients, B cells that produce IgG4, and I had to discuss them in a second, but let me just discuss them right now. B cells that produce IgG4 are incorrectly activated. So they make a lot of IgG4, and the sign of that is that 40% of IgGs are IgG4 in plasma. But that IgG4 is not causing the problem because it is not inflammatory. The problem, the fibrosis that occurs and the pancreatitis that occurs and the liver damage that occurs, that is because of cytotoxic T cells. So you might say, what the heck? We have antibodies here, we have B cells here. That is a pathology, and you're saying T cells cause the damage? Yes. So what happens is, imagine I am a T cell, and next to me is standing a B cell. This B cell is incorrectly responding to some antigen, let's say some body tissue. So it continuously becomes active. And when it becomes active, it produces IgG4, correct. But at the same time, B cell continues to present that antigen to me. It keeps saying, do you see what this is? Did you see this? And I become active. And I say, okay, I understand. This is an antigen that you're showing me. I'm going to go attack anything that displays this antigen. And I start attacking my own body tissues. That is antibody-dependent cellular cytotoxicity, or ADCC. So in the IgG4-related disease pathologies, it is the T cell that cause a problem. Now, how is that interesting here? In this finding, this IgG4 isn't sufficiently increased even within the same small type of antibody, anti-spike antibodies, one. Secondly, if something is going to activate the T cells, then the IgG1 is 72% high. That is higher. That should cause more damage than IgG4, but that does not happen. So those patients who feel that they have IgG4 related disease, at least this study's data does not indicate that they would have an aggravation of that disease. Okay, going back to the discussion. All right, so continuing, I want to review the figure 1, which is really, really important. I have been teaching this for about 2 years, but in this one diagram here, they have just put it all together, which is such a beautiful thing. So let's look at it. Oh, opening here is actually worse than here. Okay, so look at the top here, A. This is a B cell's genes. And the B cell genes from the left to right. And medical students, early physicians, and NPs, PAs, nurses, this is very important for you to know. This is a concept where I see many students struggling. I struggled when I was studying, when I was a student. So first of all, there is VDJ. So that is the variable and diversity and J region, correct? So that is the variable sites of the antibody. Then if you see here, C mu and C delta. So that is IgG, IgM and IgD production. So these are the genes. If you see here, there is this little break. What happens is the mRNA producer in the DNA, it will walk on the gene and keep making a copy of it until a stop sign is found. So in the B cells, the naive B cells, when the immunoglobulins are made, they are made up to D and M. So a B cell, naive B cell, produces always IgM and IgD together. IgM from the B cell will be released in the blood circulation or plasma or interstitial tissues, and IgD will usually stay stuck on the cell surface, acting as a receptor for it. Then comes the class switching. Class switching, for example, interleukin 4 and interleukin 5, they are the first instigators for class switching, proliferation and class switch. So what happens is that the 5 causes the class switch, that when the class switching has to occur, this part of the stop signal in the gene is removed. It is spliced out. B cell automatically cuts it and removes it. So then what happens is, what is next on the road? If you see here, it says C gamma or constant, gamma 3, gamma 1, epsilon, alpha, and so on. So if you go here as well, gamma 2, gamma 4. So this is the sequence of class switching, that the B cell would produce IgM and IgD first in the acute phase of a disease. Then it will class switch. It will change itself. So I made a diagram. Let me show that diagram as well. So let's go here. This is a naive B cell. This B cell, when it would be instigated, when it would be triggered, when it would be activated by a T helper 2 cell, then the B cell would convert into a plasma cell. The plasma cell would start making IgM and IgD. A B cell does that without any class switching. Then, as the B cells are proliferating, that is, they're increasing in number, some of these B cells would class switch. They would class switch to IgGs. Now, within the IgG repertoire, the primary IgG that is made is IgG1. And then smaller fraction of class switching occurs. That means some B cell class switch to IgG2, some to 3, and some to 4. The Ig1 and 3 are supposed to be pro-inflammatory. Why are they pro-inflammatory? Because these antibodies, I had this little wrench with me today. If you see my hands, the antibodies, I thought today I'll teach with a wrench. So here, imagine this is a wrench. So this part is the binding region or variable region. This is where it catches on to the antigen. Then this part, the handle, is a constant part. This is called the fraction constant, or FC. The class of an antibody is denoted by the handle type. Imagine we go to Home Depot or somewhere to buy the wrenches, and there are blue wrenches and the red wrenches, and there are this kind of a wrench with 2 handles, and there is a wrench with 1 handle, and so on. These are called the classes. Now, when the class switching is occurring, when the B cell produces a different kind of a handle, the variable region stays the same. So imagine if I am a B cell against the spike protein, that means I have a very specialized binding region. However, my first handle type is IgM and IgD. Then my daughters are produced. When my daughters are produced, some daughter decides that, hey, you know what? I want to switch my class. So she would still have the same variable region. Any daughter that comes from me would always have the same variable region. It would always attack the same antigen. However, the handle will become different. It will become IgG, then IgE, then IgA, and they all have different biological functions. And these biological functions are actually needed by our body. They are not abnormalities. As I was seeing some folks saying that we have a wrong kind of antibody produced. No, these are not wrong kinds. All right, so let's go back to the discussion here. So that little diagram, it shows this. So once the IgD and M are cut out, then the gammas are produced. When the gamma are produced and class switched, then if you see here, C epsilon and C alpha 2. So epsilon makes IgE and alpha 2 makes IgA. So we'll come back to this diagram in a second. I'm going to go back to my drawings. So after knowing that class switching occurs, here is a thing to keep in mind. This class switching to IgG4 is occurring more with messenger RNA vaccines than adenovirus-based vaccine. That is an interesting thing that they found. Now, is that a good thing or a bad thing is not known, at least on this study. In the study, they said, we do not see a clinical impact of it. And then they said, because maybe the study size was small, we need to have a larger study to figure out if there is any impact. Having said that, they also wrote that all of our patients, these the healthcare workers that they were working with, they all had, not all, any of them who had the infection had it mild. So regardless of what their IgG4 status was, they didn't have severe cases. Then once again, the authors write that, hey, we would like a bigger study to understand if there is any impact on that. So basically, there is no known clinical impact. It is just a very interesting machinery observation. And why it is more interesting is it happened with messenger RNA vaccine and not with the adenovirus. And that means I am spilling the beans of everything that is coming down the road in this lecture. That means authors wrote, it may not be repeated spike protein that is the problem which causes IgG4. It may be something in the mRNA. Why? Because if it was a spike protein, then adenovirus-based repeated vaccine should do the same because that also produces spike protein. But that doesn't do it. So it must be something to do with the mRNA vaccines and not the spike itself. And I'll show you where they write that as well. So going back to the discussion. Now, an antibody, as I showed you on the wrench, has a variable region and a constant region. Constant region is the handle of the wrench. Now, just like I can hold the antibody, this wrench. So if I hold it, imagine I am a mast cell or a macrophage or a natural killer cell or a neutrophil or an eosinophil. I have a special receptor, this hand of mine, to hold the antibody from the constant region. This is called Fc gamma receptor, or a receptor to bind with the IgG of the antibody. Good. So what will happen is, I'm going to use this tiny little monster that I have near me. Imagine this is SARS-CoV-2. And the one tiny spike of the SARS-CoV-2 is bound in here. And then I am a mast cell or a macrophage, and I hold this antibody from the constant region. Then what happens is there are next things that would happen, this little monster. One is that a portion here, a window here on the antibody will open up. That would allow complement system. Complements are also proteins. We'll discuss that in a second. Complement system to become activated. Secondly, the constant thing itself is working with the mast cell and natural killer, so that is also a biological function. Thirdly, once it attaches to a macrophage, for example, then macrophage would eat up the whole thing, the virus and the antibody, and that is antibody-dependent phagocytosis. Good. So the constant region does a lot of things. IgG4's constant region does not activate complement, and does not avidly bind with the receptors on the cells. It doesn't mean it doesn't bind at all, but it has low potency to bind. Okay, back to the discussion. There are questions as well. For example, Tagatser says, but doesn't the adenovirus-based vaccines end up producing the mRNA in the nucleus sent to cytoplasm in order to make spike protein via translation in the cytoplasm? Yes, but that mRNA is produced by our nucleus. It knows which nucleotides, which bases, how to make it. The mRNA coming from outside is modified mRNA. Or maybe it's not even mRNA, it's maybe LNP. What they meant was those vaccines, other vaccines that are also producing spikes, they are not doing it. So it does not look like this is spikes problem. It looks like something else. What is that else? They don't know. They conjectured that it may be mRNA because that is, we have LNP, we have no other adjuvants, and we have the mRNA. There may be something else. They don't know. Good question. Okay. Continuing. Dr. Bean used the wrench in days of Uranus cart and bicycle. Yes. So now, good that we have antibodies that can connect with the gamma receptors on mast cell, macrophages, natural killer cells, eosinophils, dendritic cells, and activate them. Okay, continuing. Next concept that was important in this discussion was avidity. Now, what happens is this wrench that I was showing you, this wrench, if you can see this in my hand, this wrench only has one binding region. Imagine I have two such wrenches, or whatever these things are called, and then I hold them both together, and each one binding region can bind to one of the monsters, one of the antigens. That is a minimum size of an antibody, that it has two binding regions. Now, please listen to this. The binding region, one binding region or variable region, and its attractiveness to the antigen, its affinity to bind with the antigen because of van der Waals forces, because of the electromagnetic forces, because of other bonds it can make, that attractiveness is called affinity. However, that is the affinity of 1. Let's call it on a scale of 1 to 10. Let's say affinity is 2. I'm just making up a number. You can make up another number, 4. But one number. So let's say the affinity is 4. Then there are 2 binding sites. That means the total affinity is 8. So avidity means total affinity of an antibody. Affinity means affinity of one variable region of an antibody. They said in the research that they found that IgG4 has better avidity. It is more avid compared to the other IgGs. So you may have this question, why? And there is a fascinating thing in here, which I think that was, so for me, this was a beautiful study. For people, it's a, whoa, we caught a rumor, conspiracy here. So check this out. What happens is, when our B cells are making antibodies, those B cells go and live in the germinal centers in our lymph nodes. In the lymph nodes, there are special cells called follicular helper cells, follicular dendritic helper cells. These cells continue to train these B cells, continue to present them the antigen, and the B cells continue to refine and improve their binding capability of the antigen. This is equal to, if we did a quick exercise here, I think today's lecture is very important. I'm sorry if it becomes long. Imagine I am a naive user of the wrench. And so I have to hold this little monster with this wrench binding site. But I did not correctly open it. So it is not correctly opened. And I'm still able to bind a little bit, but it is not a good fit. It would normally slip out. So you tell me that, you know what, Mubin, open it a little more. And so I say, all right, I'm going to try a little more opening it. And then I try to bind it. But now it is too loose. And it is still, the monster is still getting out. So then you say, you know what, okay, try to reduce this a little bit. And so maybe here it is better. And I say, yeah, it is now stuck. So this process is called affinity maturation. And this is done with two cells, follicular dendritic cells with the memory B cells. The follicular dendritic cells train the memory B cells to improve their binding capability. Now, I hope you can realize that anytime binding is improved, then affinity will improve. That is one site of binding. And because the antibody is overall, let's say IgG is 2 sites, then avidity will improve as well. IgM, do you know IgM? There are 5 IgMs that bind together, so they have 10 sites. There are 2 IgA, secretory IgA, that bind together, so they have 4 sites. IgGs have 2 sites. So when they said that avidity increased, that really meant was that there was affinity maturation going on to improve the B cells' behavior. So now here is the question. We should have the right conspiracies, not the wrong conspiracies. The right question is, why were these B cells being affinity matured 210 days after the vaccination? What was going on? Who was training them? What was the reason for training? Training occurs, the follicular dendritic cells train the B cell when there is a presence of antigen. And where was the antigen coming from? Not everybody had infection. In the second cohort, they had one person infected and they excluded that person from the tests from this study. There were 10 other people who got infected from the other side, but they were kept to see. They knew that they were infected now, and they used them to see if IgG4 appears after the infection, and it didn't. So vaccinated only, third dose only, 210 days later, something is still helping produce more IgG4s. What is that thing is not known. That is where I think we should dig deeper to say, what the heck is the vaccine doing that after 210 days, there is still activity? I feel that there are going to be some memory B cell, long-lasting memory B cells, and some cells harboring, just like the S1 proteins in monocytes, harboring those and presenting those to this combination in the germinal centers. But I do not know really what is the reality. Neither did the researchers know. They conjectured, I have done this study before, that there is a study that showed that the messenger RNA receiving persons had messenger RNA in the germinal centers for months and weeks and months. So they used the same study to say maybe it is a messenger RNA hanging out in the germinal centers where it is helping produce a cycle which causes the B cells to become IgG4 producing, class switched, plus they are still doing affinity maturation on them, and they're producing IgG4 even 210 days after. So now, this can be a good thing and a bad thing. Why it is a good thing? In many people, it would act as a protection. Why it is a bad thing? Some folks who are vaccine injured, it may be a continuity of the injury because there is the antigen present and the body is continuously producing antibodies. Now, IgG4 related diseases, their first treatment is steroids, but steroids cannot be given forever. So then the second is the rituximab. So that means, although this is not a IgG4 related disease level, but still, if some patient is long COVID, after COVID or vaccine injury, and they suspect IgG4, they can have maybe a course of steroid to see what happens, and then rituximab to see if IgG4 is reduced and if that improves the patient. This is what is interesting. We should be discussing these things, but when this noise occurs, it takes away from the actual medical discourse to say, how do we improve further? Okay, so going back to the discussion. Okay, so I have now explained what is affinity maturation. Continuing. Antibody dependent cellular phagocytosis. This is what is interesting. I said this before as well. On one end, the vaccine hesitants were saying, and by the way, my wife got vaccine injured, so I am afraid of these vaccines as well, especially the adenovirus based vaccines. So being afraid is a different thing. Anti-vaccine is a different thing. So antibody dependent cellular phagocytosis. For 2.5 years or 2 years or something like that, anti-vaccine folks had been saying, we do not want ADE. Vaccines would cause ADE. So here is a study that shows third dose would actually reduce ADE. Antibody dependent cellular phagocytosis, what happens is, imagine this is the virus. I made a bacteria here, but virus. This virus is coated with antibodies. When these are coated, the virus is coated with antibodies, we call it opsonization. Opsonization is to make the virus or bacteria or whatever cell we want to kill, the cancer cell, yummy. And what do we mean by yummy? The macrophages and dendritic cells and other cells can hold the virus coated, antibody coated thing from the antibody receptors with the antibody receptors and eat it up. IgG4 doesn't bind potently or avidly with the IgG receptors. That means it has lower potential to help with the phagocytosis, which will mean it has lower potential to clear the pathogen, which will mean it has lower potential to cause inflammation. So before you went hands up and said, see, lower potential to clear the pathogen, we have a problem. But no, the 72% is the, or 72, 70, I believed it was 78 point some percent, is IgG1 that is doing this function. So we are not at a loss. We're talking about 19% of this thing. But it would probably create a balancing effect. It would reduce the amount of inflammation produced. So ADE will reduce with this one. Then antibody-dependent cellular cytotoxicity. I discussed that before as well. What happens is that not only the phagocytes can eat up the pathogen that is coated and made yummy with antibodies and complement system, the phagocytes can actually attack that cell as well without eating it. They can release perforins. Perforins are little enzymes that will poke holes in the target cell or pathogen, whatever it is. And then they can release granzymes that would get into the pathogen and induce a killing of it, or the cell and induce killing of it. This is called antibody-dependent cellular cytotoxicity. It's a very important mechanism. However, it will also be inflammatory, plus it can cause incorrect tissue to be destroyed. And IgG4 has lower potential to cause ADCC, which is a good thing. Then antibody-dependent complement deposition. This is also a very interesting mechanism. Our body is so clever. So what happens is when we get infected, our body sends a message to liver to say, hey man, make more acute phase proteins. Acute phase proteins mean we are in an acute infection, make weapons for us. Liver becomes a weapon factory. So one of the weapon system is called complement system. Complement system proteins eventually in a higher level, they come and they coat the pathogen just like antibodies coat the pathogen. That is called opsonization. Plus this little hat that you see here, this is my attempt at making a pipe-like structure that is stuck in the pathogen to make a hole in it, which causes the internals of the pathogen to just fall out and the pathogen deflates and dies. This is called a membrane attack complex, or MAC. So complement system, once it becomes activated, it makes max. The important thing is complement system only becomes activated with antibodies. So this wrench that I've been using for the whole discussion, when this wrench is bound to an antigen, then there is a tiny window opens here that allows the landing of the complement system, attachment to the complement system, and the complement system becomes active. Then, of course, this antibody is present somewhere near an antigen, so it would attack that membrane attack complex, will punch a hole in the cell nearby, whatever it is. It is a body cell, or it is a bacteria, or it is a virus, and it is going to try to kill them by punching holes in them. IgG4 has lower potential for this function as well. Remember, I'm not saying no potential, because IgG4 by definition is not set to not be able to do these things. It just does them lesser compared to IgG1, for example. So it is relatively anti-inflammatory compared to relatively pro-inflammatory IgG1. So all ADE mechanisms are reduced in the presence of IgG4. But they're not just all stopped, because one, it only reduces them. Number two, its percentage is still not dominant. They found 4 individuals who had the whole dominant series was IgG4. Even then, they were fine. So the researchers conjectured, they thought that we do not know really what is the clinical impact of this. They also said we do not know what is the long-term impact of this. We just know that this happened, and there are more studies that are needed to work with it. Okay, so now time to just look at some of their discussion points as well. So Patrick says, is Novavax safer overall? So in this context, if you look at it, they say this is happening because of messenger RNA. If we call this to be unsafe, I don't think it is the unsafe message here. If we call it unsafe, then of course anything that doesn't have mRNA will be better. For example, adenovirus or the Novavax. However, we also know adenovirus-based vaccine has its own problem, the clotting and other issues, especially in women under the age of 50. So that should be also kept in mind. So Novavax may be better, but Novavax is a black label warning in the Europe about cardiovascular issues. So here, let's look at it. They say, in a cohort of vaccine with breakthrough infections, so this is a people, they were part of this, the cohort of the vaccine with breakthrough, we did not obtain any evidence of an alteration of disease severity. So those folks who are claiming that this study proves that people are more sick, people are dying with this, or the immune system is just switched off. Here is, in a cohort of a vaccine with breakthrough infection, we did not obtain any evidence of an alteration of disease severity, which was mild in almost all of our cases. Larger cohorts with differential disease severities will be needed to address this aspect in the future. So that means if I said that it causes severe disease, that is a problem. If I said it won't cause severe disease, that is a problem, because they said we have no idea. The ones that were part of the study, they were mild. So anyone who says this, think about it for a second. This is relatively reducing inflammation, which is a good thing in case of SARS-CoV-2 and spike protein problems, because the problem is the cytokine storm. The problem is runaway inflammation. So if the pro-inflammatory system is milded down, it is actually a good thing. Okay, continuing. So what are we finding in this? Number one, affinity maturation continues for months after. Why? That is a question. They are not able to answer that. For me, this study, I will remember because of this one issue, not because it has proved any. An inflammatory outcome of the infection will be reduced but not removed. So it is not that it is non-inflammatory and so all inflammations have stopped. and all body's immune responses have stopped. Cancers have started emerging. That's not the, at least this study does not show it. Maybe there will be another study that shows something, we'll see. This study does not show that. 70% or 80% IgG1s were still present. IgG4 were lesser. And if you read their study, they say lower potential of binding, not no potential of binding. Plus, it's not that they are overriding IgG1's function and just removing the whole immune system's function altogether. That's not happening. Now, this was also interesting that this is only mRNA. So this is something that I'll keep thinking when I'll be sleeping today, that what was in this situation, that spike didn't do it, repeated spike didn't do it, and mRNA did it, why? And there can be many theories about it. I don't want to speak them aloud because they're going to become rumors. So what is happening, I do not know. And they do not know either. Chances of ADE are reduced with this, not increased. And those folks who said that vaccines with ADEs are bad thing, they have a demonstration here that ADE is reduced. Chances of cytokine storm are reduced. So John had brought this in the beginning. This inflammation and runaway inflammation chances are reduced. Then it is a small study. So it's a good directional study, not a conclusive outcome to make decisions. Then there is another very important thing. Because there is more IgG4 would also bind less with mast cells. That means the allergic reaction like or mast cell activation like problems will be reduced with it. This may be why some folks feel better after the vaccine shot. Then look at this one. This is a very important paragraph in their closing statements. They said, interestingly, in the cohort that had 2 mRNA vaccinations before breakthrough infection, only 3 individuals developed IgG4 antibodies. So 2 shots, only 3 had. They should have given percentages. It's a small study, and to me, it seemed like even the authors were playing with the numbers a little bit. So they would say half. Also remember, this IgG4 increase was only seen in half, not all. And in 4, it was observed as dominant. But they mixed up half with 4. So now you have to do your own math by saying, okay, 4 out of 29. So wherever they thought the percentage is not going to help them, they just put the number there. Wherever they thought percentage will help them, they use that. So either the review was not great to ask them to become more consistent, or they just had something else in their mind. Anyways, interestingly, in the cohort that had 2 mRNA vaccinations before breakthrough infection, only 3 individuals developed IgG antibodies that were above the lower limit of quantification. So what they're trying to prove is that with 2 shots, there was not a lot of movement in IgG4. These 3 individuals experienced infection with the largest time difference to the last vaccination, 95 days, 201 days, and 257 days. While in the other 9 patients, the infection took place between 25 and 78 days after the second mRNA shot. So here they're trying to imply that the IgG4 had reduced the protection, and that caused within 25 and 78 days the infection. I actually beg to differ with them. Again, I'm reading to you what they wrote. So I am not misinterpreting this. I'm showing it to you so you are clear that what they said. I beg to differ with their implication here that this is somehow mRNA. They did try to connect in their manuscript to say it is because the IgG4 appeared 2-3 months later. But that is a problem then. If IgG4 itself is the problem, and then it appears 2-3 months later, then why is somebody getting 25 days after or 78 days after the infection? So take it with a grain of salt. This is what they observed. So as a data point, it is interesting. To me, it may be that somebody who goes for a 3rd shot, they may actually have a higher risk. They may have a comorbidity as well. And so But again, that's a conjecture as well. I may be wrong. This supports the hypothesis that switch to IgG4 is consequence of ongoing germinal center maturation, and it takes several months until IgG switch for memory B cells to appear. So again, that's what I said. I beg to differ with them. But this is their study. This is what they wrote. Then this phenomena isn't universal. It didn't happen with the infection. It didn't happen with the adenovirus-based vaccines. It didn't happen with one or two shots of the mRNA. It happened with the third one. So then they say, in the present study, we longitudinally tracked the antibody responses in volunteers vaccinated with 2 or 3 doses of Comirnaty for a period of at least 8 months after the first vaccination. We found an mRNA vaccine-driven expansion of memory B cells expressing IgG4. We detected spike-specific IgG4 antibody in about half of the serum samples, half, not all. So please, one important takeaway, if you're listening even now, this IgG4 is not universal. Not all IgGs have become IgG4. It's just a very tiny repertoire of IgGs against the spike protein, and within them, a percentage that went up from 4 to 19%. And this also did not happen to everyone. It only happened in 50%. And then they had no clinical data to say it was a good thing or a bad thing. Half of the serum samples collected 5 to 7 months after the second immunization, all of which did not show any IgG4 at earlier time points. For all other IgG subclasses, a decline was seen. So this is interesting that other antibodies waned, IgG4 continued. I actually like that. Good. The only problem I continue to have is what was causing affinity maturation. Finally, no substantial serum levels after the second dose, but increase after the third dose. I have discussed that before. Then, this is what I've said it many times. They said it doesn't look like it is because of the spike, but it is mRNA. So they say that adenovirus-based vaccine didn't do it, but mRNA-based vaccines did it. So remember, this phenomena is only for spike antigen. The rest of the immune system isn't bothered. Read up B and T cell selection. So if somebody feels that, no, it is just the whole immune system is now in trouble, they should just read up, Google B and T cell selection. So the cells, B cells and T cells, are selected according to the antigen that is present, and not every cell changes to IgG4. That will be horrible. That if all cells just decide today we would only make IgG4, that would not happen. And they say that in the title as well. So this is a discussion. I've taken more than an hour from you. Thank you very much for this. Happy holidays. If you like this work, I hope you like this work. If you like this work, then please support this. There are links in the description. You can buy me a coffee, or you can use PayPal, or you can become a member of this channel for, I think, $2 or $3 per month, or you can become a member of Patreon for $5 a month, and the links are in the description. So with this, thank you very much. Let me see if there are any questions, and then we close. Tex says, love the lecture that discussed mechanism. Thank you very much. I wanted to discuss the mechanism so you can do your own thinking. You might come back with a conclusion to say, no, we don't agree with you. We think it is something else. Fine. But at least you should have the mechanism in your mind. Colombian says, if IgG binds the antigen but does not bind to the Fc end, how does the complex get cleared? So macrophages can actually eat up the whole thing directly with phagocytosis without binding with the IgG receptor. So very good question. But remember that when it binds with the virus, it actually interferes with it. So it's not the wrong kind of antibody, as I read in a blog. It's fine. It just has a different behavior. It is a balancing behavior. Okay, so what else? So this is a very good question, Philip Caffs. Would Dr. Bean consider the weakened live virus vaccine? Not at all for the COVID. One. Second, China is not doing very well, and they have tried with the attenuated virus vaccine. It's not a killed virus vaccine. So I'm going to discuss that hopefully tomorrow. And if China, after all that vaccination, I heard a presenter a few days ago, much more popular than I am, saying, I'm not bothered about China. They'll be fine. They have this. And now China's in trouble. So let's have that discussion tomorrow. The devil's advocate says it's not a vaccine, so you can't really be a vaccine. It is a vaccine. Okay. Finn Frog says calling us vaccine hesitant is really downplaying just having common sense. Oh, really? What should we call anti-vaccine? So all right. So with this, thank you very much. Please like, subscribe. There are some very angry people here in the comments. Please like, subscribe, and share. And I would see you tomorrow for China. Yes, there are some folks who are doing a lot of fear mongering. If you like to be in that group, please, more power to you. Bye-bye for now.